Okay, good morning, everyone. A couple of announcements before we begin. So this was the last quiz of the quarter, quiz 7. Typically, my goal at the beginning of the quarter is 7 to 9 quizzes. So we met that goal, 7 quizzes. In fall, I'm able to do around 8 or 9. 7 quizzes, about 15, 20 minutes in length, is at least equal to, if not more than 2 midterms. And so that's my reasoning behind, at least a target goal of 7. Okay, so this is going to be the last quiz of the quarter. Then let's talk about the final exam. The final exam, in case you haven't checked it out, has been there on the front page since the beginning of the quarter. Basically, it lists all the options that are available to the students. First of all, final exam is not optional. It is mandatory. You can choose to skip it, of course, but you would earn a 0 on the exam. If you're happy with your grade as it is, you can subtract 20%, and that would be your grade. That would be your final grade. Okay. There is no Zoom option. All final exams are in person. When I say all final exams, I'm referring to the options. Okay. It's not as if you have to take more than one final exam. It is not a take-home. It is an in-person exam. This is section 02. So your final exam, according to the university, is scheduled on Monday. Next Monday, exactly a week from today. It's at 10 o'clock. Almost to the T. Basically, if you're taking the exam on Monday, you'll be doing the final this time next week. All right. That makes it easy to remember. Monday at 10 o'clock, class time. Well, if you wish to take the exam at the university scheduled time, you do not have to do anything else. You simply show up next week. All right. For any of you who wish to take the exam at any other time, there are a total of 4 options. The regular time being 1. The other one is the Saturday final. So there is a final that I've scheduled on the Saturday of this week, which is the Saturday before finals week. Several students, and I've been doing this for every quarter because several students do like to get the non-E major class out of the way and concentrate on the major classes during the week. So again, this is optional. Okay. The choice is an option. I'm not forcing anyone to take it on a Saturday. If you do wish to take it on a Saturday, you simply let me know in the form that is at the end of this page. Right? No explanation needed. But I do need to know who wants to take it on a Saturday, so I print out enough exams. And that's the reason I need a count. I need a head count. The Saturday final is most likely going to be in room 126. Yes. As soon as possible. Some students have filled it out, submitted it like early in the quarter, like the first few weeks of the quarter. So yeah, let me know as soon as possible. I'll print out the exam sometime on Thursday or Friday. So I need to know. So far, I think there are less than 10 students who have signed up for the Saturday final. But again, as more and more responses come in, students have more time to think through. I expect that number to go up. If you wish to take the exam on Monday, again, you do not have to fill out the form. Okay, Monday at its regular time, which is 10 o'clock in this classroom, right? Which is this option right here. We are section 02. Our class begins at 10 o'clock. So if you plan to take the exam at its regular scheduled time, you do not have to submit the form. If you wish to take it on Saturday, you do submit the form, but you do not need to explain why you're taking on Saturday. If you wish to take it, there are 2 other options or 2 other times. If you want to take it on a Wednesday, which is from 7 o'clock in the morning, well, then you do have to let me know. Okay. And the reason is there is limited seating in this classroom. So the exam would be in this classroom. So it's a first come, first serve option. Typically, I never have any issues because students move around. Some students from this class might take it on a Saturday. Some students might take it on some other day. And so there will be space. So if you do want to take it on a Wednesday or the Monday at 1 o'clock, well, just let me know. But you have to let me know by submitting the form. Okay, again, so that I have enough exams printed for every one of you. do not just show up other than your university schedule time. Other than that time, do not show up without letting me know. I may not have an exam for you. So please submit the form and let me know if you do plan to show up at the alternate time. All right, so the question is then, there are 4 days and times that are as an option, right? Exams are all going to be similar. They won't be exactly the same, but the level of complexity, the number of problems, the questions, the points, they will all be exactly the same. Questions will not be the same, but they will be similar. Taking it earlier or later is not going to hand any student an advantage or put you at a disadvantage. Okay, so if you do wish to take it earlier, it's not going to put you at an advantage or disadvantage. The only advantage is you'll be done with one of your finals early enough. All right. All the topics that you need to study are already listed on here. Typically, I give the Friday before the final. I either just do like a 10 or 15-minute overview, or I just give it off. I just give it off to students, so students can just take the time to study, or maybe catch up on extra sleep if they want. So I will decide by Wednesday, and I will let you know what we will do about Friday class. All right. All right. Any questions from anyone? Anyone at all? Okay. Well, let's continue with our discussion of first order filters. So section 2, chapter 6. We were talking about RC low pass filter, and we talked about the frequency response transfer function, the quick and easy analysis by modeling the capacitor and inductor as a open or short circuit. So any questions? Any questions on the operation of this filter? Just as a brief recap, the circuit is a resistor and capacitor in series. We take the output across the capacitor, and we can prove either by the transfer function or this quick and easy analysis that when the incoming input frequency is low, meaning as f tends towards 0, it works as a low pass filter. And the reason is, as f tends towards 0, capacitor behaves like an open circuit. If it behaves like an open circuit, whatever input we give to the circuit appears at the output, meaning V in is allowed to pass through to the output. And so it works as a low pass filter. At higher frequencies, capacitor behaves like a short circuit. If we try to now take the output across the capacitor, electrically speaking, the two ends of the capacitor behave as if they're this exact same junction, electrically speaking, not physically. So when you try to take V out, voltage is the difference in electric potential between 2 points. If both points are exactly the same, then there is no difference in electric potential. If there is no difference, that means voltage is equal to 0. So if voltage is 0, effectively V in is being blocked from reaching the output. And so we say high frequencies are blocked, low frequencies are allowed to pass through. And that's how you would perform the analysis for any kind of filter circuit. Does that make sense? And of course, we can derive the transfer function. The transfer function is 1/1 plus JF over FB. FB is the break frequency where the transition takes place. Real life and ideal filters, as frequencies below FB are allowed to pass through, frequencies higher than FB are blocked. Now, yes. Is what? It's not an instant cutoff. No, it's never an instant cutoff. There are higher order filters like second order, third order, fourth order, higher order filters that will try and approximate the ideal response, where you would have a pass band will be almost flat, and then the slope, instead of being a very gradual slope, it'll be a very close approximation of an ideal filter. let's say. There are some trade-offs, and again, filter design is an entire subject or entire course by itself. Okay, so this was a series circuit, right? Series circuit. Instead of taking the output across the capacitor, what will happen if I take the output across the resistor? What kind of filter would I get? There's only one other kind of filter. If this is a low pass filter, you would get a high pass filter. So if you take the output across the resistor in a RC circuit, you get a high pass filter. Effectively, this is the exact same circuit. There is no change. You have a capacitor and resistor in series. It seems as if it's different, but it's not. Now, for practical considerations, we would want V out to share the exact same negative terminal or ground terminal as your incoming input voltage. And so we switch the connections of R and C. But theoretically speaking, it is still a series connection of R and C. If you find the total, if you determine or calculate the total equivalent impedance, it will still be R plus ZC. You would still apply voltage division. You would still have the exact same current flowing in the circuit. Everything will be exactly the same. And that's the reason why I say it is the same circuit, but you're simply switching the location of your output. Series circuit, you take the output across the capacitor, you get a low pass filter. Same series circuit, you take the output across the resistor and you get a high pass filter. And I can show this by performing the quick analysis. As F tends towards 0, capacitor is replaced with an open circuit. Output is across the resistor. What is V out? If capacitor is open, there is no way for V in to go or reach the output side. So V out is equal to 0. Right? So V out is equal to 0. On the other hand, as F tends towards infinity, capacitor behaves like a short circuit. And capacitor behaves like a short circuit, V in reaches the output. And so V out is equal to V in. Low frequencies are blocked. High frequencies are allowed to pass through. Hence, it works as a high pass filter. Same circuit, you're only changing the location of the output. And this is typically what might happen in a in like the speakers that we have mounted here as an example. There might be a small RC filter circuit. And that RC filter circuit, the output of the resistor would go to the tweeter, and the output of the capacitor would go to the base or the woofer. Woofer driver. So this, more likely than not, is a two-way speaker. So it would have a woofer, which is the large speaker, tweeter, which is the small, reproduces high frequency. So every one of these kind of speakers would have a simple filter circuit inside it. I'll talk more about that on Wednesday. But does this make sense? The analysis, again, analysis is straightforward. R plus ZC, apply voltage division. You calculate V out across the resistor, meaning the voltage across the resistor. So VR is equal to V out. You rearrange the terms, V out over V in, obtain the transfer function, which is very similar to the transfer function for a low pass filter, but it now has an additional term in the numerator. The denominator is still the same. 1 over 1 plus jf over fp, but now the numerator also has jf over fp, where f is the variable, it's a function of frequency, fb is the constant, which for a RL filter, oh, sorry, for a RC filter still remains the same. Okay. So RC low pass, the break frequency was still 1 over 2 pi RC. A RC high pass is also 1 over 2 pi RC. This is true for all first order RC filters, meaning one energy storage element. If you can combine all capacitors in a circuit, reduce it down to one single element, it'll still have this exact same equation for FP, 1 over 2 pi RC. High pass filters have a different transfer function. Okay, different transfer function. Again, students do not have to memorize any of these, right? You can have these on your equation sheet. This operation makes sense. All right. Any questions? Any questions at all? So if we take a look at the RC filter, what happens if you switch out this capacitor with an inductor? Capacitors and inductors are duals or opposites of each other. If you take the output across a capacitor and you obtain a low pass filter, what would happen if capacitor is replaced with an inductor? Only one other option. High pass, RL high pass filter. So if you replace the capacitor with an inductor, you get a RL high pass filter. Exact same series circuit. Take the output across the inductor. It is a high pass filter. You take the output across a resistor, becomes a low pass filter. The transfer function for a high pass remains the same, whether it's made out of RC or RL. The break frequency is different. Break frequency is R over 2 pi L. Analysis can be performed in the exact same way. Find the total impedance. Total impedance would be R plus ZL. R plus ZL. You find VL applying voltage division. And rearrange the terms because V out is equal to VL. V out over V in gives you H of F. All right, any questions? Let's take 10 seconds. Think on it. Let me know if anyone has any questions. Again, quick analysis. As F tends towards 0, inductor behaves like a short circuit. V out is equal to 0. Again, trying to take the output across the same 2 points. V out is equal to 0. So low frequencies are blocked when F tends towards infinity. Inductor behaves like an open circuit. J omega L, J2 pi FL. and high frequencies are allowed to pass through, and hence a high pass filter. Okay. It's the same two circuits, series connection of R and C, series connection of R and L. Okay, depending on which component you're taking the output from, you can change the function of that filter. Well, you're not changing the function, but you're changing how you want to apply the circuit. So out of 4 possible combinations, I did the analysis for 3 of them. The 4th one is if you take a RL circuit and you take the output across the resistor, which I noted above here, you would get a low pass filter. Okay, you would get a low pass filter. So a RL low pass, same series circuit. Now the output is across the resistor. I would assign this as student practice. And simulate the output at low frequencies and at high frequencies. It shouldn't take longer than a few minutes. The transfer function of a RL low pass filter is the same as the RC low pass filter. Break frequencies for RL filters are R over 2 pi L, or 2 pi FL, 2 pi L. And the same for a RL high pass filter. So RC filters, whether it's high pass or low pass, is 1 over 2 pi RC. For a RL filter, whether it's high pass or low pass, it is R over 2 pi L. Okay, it depends on the values of the components. And the transfer function is the other way around. Whether it's made out of a capacitor or inductor, a low pass filter has the same transfer function. Same for a high pass filter. Whether it's made out of a capacitor or inductor, a high pass filter has the same transfer function. The characteristics look exactly the same. High pass filter, you would have a rising slope where this is the pass band and this is the block band, less than FB and higher than FB. And for a low pass, this is plotted as magnitude of the transfer function. So that's why it seems like it's not, that's why it seems a little weird. But again, that's for an idealized, it's for a real filter. That's how it would look for a real life filter, right? So this is pass, and this is block, greater than FB, less than FB. Filter circuits will affect the phase and the magnitude of the incoming signal. Okay, so the magnitude reduces in a low pass filter. The phase changes from 0 to minus 90 degrees as the frequency increases. Exactly at the midway, not midway, exactly at break frequency, the phase goes to minus 45. It works exactly the same way for a high pass, but now it goes from 0 to 90. So a high pass goes from 0 to 90. And at FB, it is 45 degrees. Okay, it's at 45 degrees. So for a low pass filter at FB, it's minus 45. For a high pass, it is 45 degrees. So it alters the phase. Now, again, this is all a lot of information, but when you actually start to solve problems, you'll simply calculate the output. If you have to find the phase angle or the magnitude, you'll automatically just do multiplication or division of 2 complex numbers, and you'd be able to find the phase. That's where this chart actually comes from. Okay, it's a standard chart. The ratio of V out to V in, and hence the highest output in that filter will always be 1, right? V out can never exceed V in. V out can never exceed V in. That comes in active filters. Active filters is where we take an op amp and apply a gain. So that's different. But passive filters like these, which do not have an active component in there, V out can never be more than V in. So magnitude of H of F will always be 1. That's why the graph looks like that. Okay, questions? Any questions at all? Here is the summary of the magnitude and phase equations for a low pass and high pass filter. Obviously, again, not going to ask you to memorize any of these as long as you know how to actually use these equations. So review the material while it's still fresh. We'll end class here today, and I will see you all on Wednesday. We should be able to wrap up, most likely we should be able to wrap up everything on Wednesday itself.